Hey gang, this Labcast is about the antibiotics sensitivity lab. In this lab, what we're looking for is the effect of different antibiotics on bacteria, on two different strains of bacteria, E. coli and B. cereus. So some of the materials, of course, we have our sterile pipettes that we use for the bacteria solution. We have forceps for transferring the antibiotic disc. We have our plain agar plates, and we have our antibiotic disc. And each of these has a different type of antibiotic on it. So if you look at the label, you'll see, it's hard to see, but this says S10, and you kind of have to look on the labels for the other antibiotics. This one, if you can see, is GM10. Anyhow, so in the fridge, you want to make sure you grab the appropriate L'Oreal broth agar plates. Make sure you look at the label on the outside of the package. What we're going to do is we're going to one plate for each type of bacteria. Remember to clamshell. And we're going to put our liquid bacteria and spread it. Locate the glass vials with the E. coli and or B. cereus bacteria. I would have the teacher put 2 to 3 drops of the bacteria onto the agar plates for you. Use forceps to remove antibiotic discs from the bottom of these vials, or just to remove them from plastic bags. To get the antibiotic disc from one of the vials, you just open it from the bottom. Then you get forceps. It's in alcohol bleach water, so be careful. Then you just push the disc to one side and then pull it from the other side. And it might be a little bit hard, but you'll get it eventually. You'll have your antibiotic disc spread in different locations onto the agar. And then what we're going to do is measure something called the zone of inhibition. Let's look at some sample results. So we see this petri dish with bacteria growing all over it. Then we have our antibiotic disc. And you see these circles around the antibiotic discs are sort of like dead zones. We call those zones of inhibition. And this indicates to us that that bacteria is not growing. It's been killed by the antibiotic. So the larger the zone of inhibition, the more bacteria that has been killed. The smaller the zone of inhibition, the least amount of bacteria have been killed. So we're going to measure the diameter of the zone of inhibition to determine the effectiveness of each different type of antibiotic on E. coli and B. cereus.